There are some Boolean expressions involving in the working of a carry look ahead adder, which is extension from a full adder. If we can understand the full adder, it's very easier to go ahead with the carry look ahead adder. And the Boolean expressions, if you are here, you might have done with the basics of half adder and a full adder. So for a full adder with 3 inputs, we're gonna have the Boolean expression for sum to be A exclusive or B exclusive or Cin, and this expression comes when we go to the basics of a full adder. And then another output carry out, which is given as A exclusive or B is ANDed with Cin, and now this product is ORed with, not exclusive OR, it's a OR operation between A and B. Alright, it's an OR operation between this product and this product. This is for the sum and this for the carry. This has, the general basics of a full adder. We're gonna have, if you say that it's a full adder, we're gonna have 3 inputs, Cin and A, B being the output. The output we have from a full adder is like sum and a carry out, C out, carry out from a full adder. Now this C out from this stage will be acting as input to the next stage, Cin as input to the next stage with the A and B as the output, and also we're gonna have that sum and carry out of that stage also, even this is a full adder. And so now this C out will be acting as input to the next stage, next consecutive stage, Cin. C out of this will be Cin of this stage with once again A and B as the inputs, Cin as the input, and so we're gonna have that sum and also C out from even this stage. This is a full adder with 3 inputs and 2 outputs. Now this C out will be acting as input to the next stage. Even this is a full adder with 3 inputs. C out of this stage will be acting as input to this one, Cin, with A and B as input, Cin as the A, B, Cin as the inputs. Also we're gonna have that sum and C out. This is the like the circuit diagram. This is the arrangement for a parallel full adder, 4-bit parallel full adder. From the picture, from this array, this will be the C out. All right, C out. Now if we say that this is the first stage, full adder 1, here the actual important points arises to be remembered to avoid the confusion in the bigger Boolean expressions which we come across the working of a carry look ahead adder. This is the important one. If I say this is the first stage, this is going to be A1, B1, Cin1 are the inputs, and C out 1 is the C out carry out, and sum 1, giving the names. And if this is the second stage, this will be A2, B2, Cin2, C out 2 and sum 2. And for the third stage, this will be A3, B3, Cin3 and sum 3, C out 3 even. And for the fourth stage, it's a C, A4, B4, Cin4, carry out 4 outputs, sum 4. Now what we have to understand from here is, in the parallel adders, C out carry out of the first stage will be acting as input to the next stage. In the sense, what is that expression for C out? General C out is over here, isn't it? Then now guys, this will be called as propagate carry. A exclusive or B is P, propagate carry into Cin, and this one A and B, this will be generate carry, so G. What it means, irrespective of Cin, definitely the carry depends on this product, this AND operation between this one. So this is not a generate carry and this is propagate carry. This could be understood from the internal circuit of a full adder with 2 half adders, which we like, yeah, this one, it's written in short form. All right, C out, this C out is P C in plus G. For C out for the first stage, C out for the stage 1, C out 1, that will be P1, C in 1 and G1. This has to be remembered, very much important. And also this Boolean expression is equal to something. What is that something? C out 1 is also equal to C in 2, which is also C in 2. C out 1 is the same as C in 2 in the parallel adder. And once again, if we talk about the second stage, what is that C out? The general expression for C out, it's P C in plus G, isn't it? And if we are talking about C out 2, this will be P2 C out 2. C out 2 depends on A2 B2, which is exclusive operation P2, and C in 2 and G2. And the C out 2 P2, okay, C in 2 is this one, so plugging in the expression for that one, like in the place of C in 2 we're gonna go for this one, P1 C in 1 plus G1, and this has to come down G2, and opening this one, P1 P2 C in 1 plus P2 G1 plus G2. This is the Boolean expression for C out 2, which is also C out 2. C out 2 is here, which is also C in 3. C in 3. So input for the third stage we'll be making use of this Boolean expression and carry look ahead adder. So this is the second stage. What about the third stage? C out 3. C out, in general C out is P C in plus G, isn't it? Plus G. So what will be, if we are talking about C out 3, that will be P3 C in 3 and G3, and C in 3 is something else here, C in 3, the same C in 3, so we're going to substitute this one, C out 3, that will be P3 as it is. In the place of C in 3 we're going to plug in this one, which is P1 P2 C in 1 plus P2 G1 plus G2 in the place of C in 3 plus G3 as it is, that which is P1 P2 P3 C in 1 plus P2 P3 G1 plus P3 G2 plus G3, opening this one. All right, did we miss something? P1 P2 P1 P2 P3 C in 1, P2 P3 G1, P2 P3 G1 plus P3 G2, and G3 appears as it is, isn't it? So this is the Boolean expression for C out 3, which is equal to, from the full adder, I mean parallel adder, what it says is C out 3 is same as C in 4, isn't it? So we make use of, in the case of full adder, of parallel adder, what it says is C in 3 has to wait for the commencement of C out 2, C in 4 has to wait for the commencement of C out 3, which is time consuming. And but these Boolean expression says, once again, let me repeat, C in 3 should wait for the commencement of C out 2, output of the previous stage. Third stage input depends upon the output from the second stage. All right, this is what happens in the parallel adders. But coming to the Boolean expression, C in 3 is not involved with C out 2, it's independent of C out 2. The C in 3 can be, I mean, if we have a Boolean expression, if we have a combinational circuit giving the output, then without any connection with the C out 2, we can produce C in 3. And from the parallel adder, once again, C out 3, C in 4 depends upon C out 3, whereas C in 4 from this Boolean expression it says C in 4 simply can be produced the same time C in 1 is given. This C in 4 does not need to wait for C naught 3. These arrangement says, in the sense, guys, carry look ahead adder isn't something different, but it's a modification of the parallel adder of this one. In the sense, this doesn't need, C in 3 doesn't need to wait for C naught 2, and we don't consider this C naught C carry out from the second stage. It's nullified. We don't consider that one. We're gonna have another combinational circuit, different combinational circuit to produce this one. We don't need to carry look ahead adder doesn't need in a carry look ahead adder, this stage doesn't need the output from this stage. We're going to have another combinational circuit the same time C in 1 is given, and which produces C in 3. In the same way, unlike in the parallel adder, C in 4 doesn't need to wait for C commencement of C out 3. But if we have a combinational circuit, another combinational circuit over here producing this one, C in 4 can be activated. The input over this stage can be at the same time the first stage gets. Alright, so these are the Boolean expressions which we have to wait. And what about C out 4, the fourth stage? C out 4, that will be, what is C out actually? C out is P into C in plus G, isn't it? So if you say that, if we talk about fourth stage of carry, it's P4, C in 4 and G4 to be remembered. C in 4 plugged in over here, or else we have a C in 4 over here which can be used to calculate the C out 4. Alright, so these are the Boolean expressions in connection with the carry look ahead adder considering an input. So these are the expressions. Okay, does it really work with practically? Yes, of course, with an example. Alright, considering a 4-bit numbers, for example, 1 1 1 0 should be added with 0 1 1 and 1. This becomes our A part, A input, and this becomes our B input. In that case, right, moving from LSB to the MSB, this one will be A1, this one will be B1. This A1 is 0, B1 is 1. This will be A2, this will be B2. This will be A3 and B3. A4 and B4. Alright, so we're gonna need the exclusive operation and AND operation. Let me write that here itself. Fine. So P1 is exclusive OR operation between these two. 1 and 0, that will be 1, and G1 is the AND operation between this one. So 0 and 1, it's a 0. Once again, P2, we need P1, P2, P3, all that, right, to plug in over here and then get the result straight away. P2 is the exclusive operation between 1 and 1, that will be 0. G2 is the AND operation between 1 and 1, that will be 1. And here P3, exclusive OR operation between 1 and 1, that will be 0. G3, AND operation between A3 and B3, that is 1 and 1, that is G3, that will be 1. And P4, which is exclusive operation between 1 and 0, that will be 1, and G4 AND operation between A4 B4, that will be 0. Remember this one, because we gonna calculate all these. C in 4 we need P1 P2 P3, C in 1 P2 P3 G1, like all that. Alright, so what was the example I considered? It's a 1 1 1 0 and 0 0, 0 let me not change the values. 0 1 1 and 1. So the sum should be 1 over here. It's a 2. It's a sum is 0 with a carry 1. It's a 3. Sum is 1. Carry is 1. It's a 2. Sum is 0 and carry is 1. So we have to have, if we add 1 1 1 0 and 0 1 1 1, if we add these two, we need to get 1 0 1 0 1. All right, so that's the working example. Let's try over here in the circuit. So what with the AND? We don't have any previous carry, guys. We don't have any previous carry, so C in 1 is always 0. So remember that one. All right. So C out over here, let's calculate C out over here. What is C out? It's a P1 into C in 1. C in 1 is 0. So this AND operation will be 0 plus G1. G1 already we have here, which is a 0 and it's a 0. Alright, C out 1. It's a 0 over here. And the same thing will be C in 2. In the sense, for the second stage, C in 2, which is equal to C out 1, it's a 0 over here. It's a 0 over here, that's okay. But let's check with the sum over here. Let's check with the sum. With C in is equal to 0 and A1 is 0, B1 is 1. A1 is, it's a 0 over here, it's a 1 over here. So for this full adder, the input is 0, 0 and 1. So sum will be exclusive operation 0, 1 exclusive, that's 1, and 1 0 exclusive, that's 1. So for this input, the sum is 1. Alright, the sum is 1, and the carry is the carry out is found out to be 0, which is also input to this one. And what is A2 B2? A2 is 1, B2 is 1. Here we're gonna have 1 over here, we're gonna have 1 over here, it's a 0. So the sum being the exclusive operation between A2 B2 C in 2, 1 1 and 0, exclusive operation between 1 and 1, that will be 0, exclusive operation between that 0 and this 0, it will be a 0. That's for the sum. So sum should be 0 over here, and carry, we don't need the carries to propagate in the next stage, so we don't carry that. We don't talk about carry out 2. Alright, and we need 3 inputs for this stage also. So A3 is here, A3 is 1. We're gonna have A3, let me erase this one. A3 is 1 from the example we considered. B3 is also 1. B3 is also 1. Let's see what will be C in 3 for these inputs with the C in equal to 0 and whatever P1, P2, P3. Here we are trying to get the value for C in 3, isn't it? C in 3. P1, P2 I'm not considered. C in 1 is 0, so this will be 0. That will be 0 plus P2 and G2. P2 is 0, so making this one to be 0 plus here P2 is 0. Even if this doesn't need to be discussed. P2 is 0, so this will be 0 plus G2. G2 is 1. G2 is 1, which is for C in 3. C in 3. In the sense, we're gonna have a 1 also, a 1 here. We're gonna have another input to be 1. So with 1 1 1, the sum is 1 exclusive 1, that will be 0. That 0 resultant 0 exclusive 1, that will be 1. In the sense, I'm talking about the sum. Alright, some expression for sum is A exclusive B exclusive C in the sense 1 exclusive 1, that will be 0. That 0 exclusive 1, that will be 1. So sum over here will be 1. And we are not bothered about C out 3. Alright. In carry look ahead adder. Getting back to C in 4. C in 4 is this one and this expression here. This one will be 0. In the sense, this because of C in 1 is 0. It's 0 plus P2, P3. P3 is 0 over here. So this will be 0. P3 is appearing again over here. This will be 0, this will be 0, whereas G3, it's a 1. G3 is a 1, so this one will be this one. See, this will be 0 because of C in is 0. This will be 0 because of P3 is 0. I am not checking for P2, even P2 is 0. Alright. Even this will be 0 because P3 is also 0. G3 is 1 over here, which is C in 4. C in 4. In the sense, we're gonna have this full adder will be having 1 because of C in 4 and A4, B4 values, these are A4 and B4, 1 and 0, 1 and 0. This full adder will be having 1, 1 and 0 as input. Now the sum for this stage is also exclusive operation between 1 and 0, that will be 1. Alright, exclusive between these two is 1. The resultant and this exclusive 1 and 0, it's a 1. 1, we have 1. 1 in this, 1 exclusive, this one, that will be 0. The sum over here, it will be 0. What about C out 4? Carry out 4. So guys, carry C out 4. What is C out in general? It's P, C in plus G, isn't it? And if we say that we talk about C4, it will be P4, C in 4 and G4. And C in 4 is found out to be 1. P4, what about P4? It's a 1. Guys, it's a 1. Alright. P in 4, it's a 1. P in 4, it's a 1. And C in 4 is also a 1. Alright. C in 4 is also a 1. Plus whatever, G4 maybe 0. But finally C out 4 is a 1. C out 4 is a 1. Here we're gonna have 1. So the result is 1 0 1 0 1. The final output from the look ahead, carry look ahead adder, 1 0 1 0 1. And where is that? We considered 1 1 1 0 0 1 1 1, and the sum is 1, no carry. It's 2 0, sum is 0, carry 1. It's 3, sum 1, carry 1. It's 2, sum 0 and carry 1. 1 0 1 0 1 1 0 1 0 1. This is how a carry look ahead adder works.